Okay, so in today's class, we look at a new dimension of DevOps, which is recently emerged called MLOps. Okay, and I'll also talk about operations for VR AR products and operations for blockchain system. Okay, okay. So let's focus on MLOps. Okay. So MLOps is nothing but operations for machine learning teams. So far in this course, we have seen operations for development teams who do typical development, in-house tools, SaaS, PaaS, iPaaS products, etc. MLOps teams do a different products which aim to decide or which aims to provide decisions and insights to the leadership or business owners who end up relying on the outcome of these teams. Okay, I don't know whether you are aware of it. There is something called virtual reality, which is also another dimension of products where people build VR products for head-mounted devices. Are you aware of any? Did anyone experience VR products in the before?
Yes, sir, long back.
Okay, good. Yep. Anyone else apart from Ashish? Okay. So let's look at the team comp. So I think then it's let's not talk about all these things. Just talk about MLOps then. Okay. So let's look at the team composition. Okay. So that that way you will actually understand how that team actually looks like. Okay. So in every ML team, you have three sections. One is data section, then people who do model, and then who do maintain and curation. Okay, this is typical broad team structure. This is how people create ML teams. Okay, who fits in data? Your typical data engineering team. Okay, people who write ETLs, people who write data transformations, people who write API to API reading jobs, data reading jobs, data collectors. Okay, data
Basically,
engineers. Sorry, hello. Okay, yeah. So people who collect data, all the external sources, they create data warehouses, they create data lakes. Okay, so these are the typical people who sit in the mod data end. Okay, then comes in the model, you will have domain experts whom you rely on to understand this data. Then you have people who label that data, you have people who write implement algorithms like typical ML engineers, you have decision scientists, data scientists testing, data scientists validators, all these people come in typical model team. In maintenance and curation team, you have data scientists who curate the models with new data samples and evaluate its performance. Okay, and then provide benchmarks. Okay, this is their job, and that benchmarks are tested by typical ML QA teams, and they release the ML products. Okay, this is how a typical ML team looks like. And what ML Ops does is they provide operational support to all these people, because the way they write code, the way they test, the way they build the code, and the way they release the code is not conventionally equal to how typical dev operations do for our regular dev teams. Okay, how, why, we will look at it in upcoming slides. Okay, this is our typical ML team looks like. So if you're applying for an ML job, typical early level ML jobs, if you're right after graduation, they'll keep you somewhere in data team or in the model team. Okay, People who are very experienced will evaluate multiple algorithms. People who have way more experience who are in leadership, they work on curation, benchmarking, and then testing and release. Okay, so let us look at um, the eventual flow of the offerings which these people work on. Okay, where is the new slide? Sorry, one second. Okay, here it is. Yeah, cool. Now let's take a data engineer. Okay, now if you observe, typical data engineer uses SQL, NoSQL. His ETL packages are written in tools like Airflow or SSIS for Microsoft or any other tool. All these code will typically go to conventional Git. Okay, but if you look at the model teams, their file formats are typically different. Okay, they typically use HDFI files, okay, which are TensorFlow files or Keras files, or they use Open Neural Network Exchange format, which is ONNX. Okay, and some people use predictive model markup language, which is PMML, which is widely used, which is nothing but an XML type of a data file, which is widely used by R and Python programs. And some people use Pickle. Okay, Pickle is like a Python specific uh, data object, mostly utilized by scikit-learn modules. Okay, and some use JSON, some use XML, some use other formats. Okay, now the challenge here is versioning of these files are slightly difficult. Okay, because if you look at these files, you have line numbers, git changes, etc. But here, when someone is working on model, the quantum of changes are very very high, because in a given day 100 people will touch one model file, because they're working in different pieces for a different data object for different set. So the number of change requests that come on one model file would be pretty high. Okay, so that is why what they do, they use uh, git tools, especially I think Jenkins and Bitbucket, which supports these builds. Okay, what they do is, when they build, they don't build like how conventional dev teams build, like daily, weekly. They build only after they reach a certain benchmark defined by them. For example, if they expect the model to generate 80% accuracy, then only they will eventually move the model to the respective production. Okay, now what do they do? They basically use tools like ML flow. Okay, there's another tool called Comet ML, which I've just seen. I've used ML flow, but I didn't use Comet ML. It will actually help you track how your model is behaving. I mean, where are the enhancements? What is the life cycle? Who are doing what experiments with that model? Did the experiments run successful? Did the experiment failed? It also looks at the performance metrics of the model. For example, there are metrics like accuracy. Okay, there are metrics like recall, and there are metrics like um, I think first set, first fit. Okay, first set and first fit, which actually tells you, can it do bare minimum validation, or can it do, does it require a particular benchmark. Okay, and some use F1 score, or some call it fit score. Okay, so, and also there's something called precision. So they use accuracy, precision, recall, fits, first fit set, fits, F5 score, to see on the experiments people are using on one ML model. And once the model reaches certain benchmark, then they will push all those change set files into Git. Until then, they share that model among each other until it reaches that accuracy. Okay, so that's what will typically happen at the model level. These are the files. Okay, when you look at the curation team, they will pull the checked in benchmarked model from the Git and then expand on new test data, new train data to refine the benchmark percentage. So if it was checked in at 70, then they will try to achieve 81, 82, 83, 84. They set a new benchmark and they push it. But for model team, the 80% is actually the V1 version. Okay. And whatever they work on, the new one, it will be under V1 version only. Okay. But typical curation team will create V2 version and try to extrapolate on top of it. That is why if you see ML products, like for example, your restaurant recommendation, or if you open Swiggy and try to figure out what do you want to order, it reads from your past orders and suggests, right? Typically it does that activity. So when someone is working on 80% accuracy, that V1 version still exists, but after the curation, if it reaches its max accuracy, they will push that version to production. That's how it goes to. Let's take an example of Swiggy. Okay, that's how it goes to a Swiggy platform. Now, if there is a bug identified, if the model is not able to predict or do the job it is trying to supposed to do, they will retract that V2. Okay, they will retract that V2 and they will again go back to the versions which is closer enough. Okay, so for example, there is a very good example which came up recently. There was location tracker. I think it's typically by Google Maps. Okay, so what it was trying to do is it is trying to identify the your journey paths. For example, you are daily traveling from your home to office. Okay, and imagine you travel on Monday, Tuesday, Wednesday, Thursday, Friday, and you don't travel on Saturday, Sunday. Okay, Google will sell this data to people like Uber, Rapido. Okay, and imagine you book daily a bike to travel these distance. And imagine if you forget to travel on particular day, it will actually read your history and will tell you, hey, you have to book a bike at 9 a.m. Do you want me to book it or not? Okay, you have that feature now in Uber. When it was first introduced, they are actually reading the paths from the Google Maps. Okay, I think in 2022 or 23 they are reading the paths from Google Maps. The Google Map algorithm in giving the shortest path for these people who travel from point A to point B using Uber was around 60 to 65% accurate. Okay, then they released another model with claiming that, let's call it V1. They claimed another model calling that this V2 is like 80%. Okay. But when it went to production, it figured out that it is not predicting time correctly. For example, a person starts at home at 7 a.m. and reaches the target at 8 a.m. Okay. So he's supposed to book something between 6:45 to 7. Okay. Let's assume this is the time. This data should help the Uber to predict whether this fellow is started. If he didn't start, can I do a recommendation notification between 6:45 to 7? The claim was it was doing 80%, but instead doing at an AM, I think it was doing at PM and also at a different time zone. So someone who trained on top of a different data set might not have trained properly with good label data, or might not uh, uh, trained it with the data related to that country, which assumptionally intrinsically made the accuracy higher, but it didn't work on the field. So they retracted V2 and bought V1 back to production. Okay, at least 65% it was working fine because its true accuracy later was found to be 55%. Okay, so there are certain mistakes which happen in ML world because most of them depends on your train data, your test data, and if it is not pruned enough, you will end up with this model problem. So all these ML companies figured out that, hey, I should not kill my V1. I should not kill my V1.1, 1.2 when I release V2. If this doesn't work surprisingly for some reason, I should have an ability to bring back this version to production. Okay, which typical Git tools may not be able to handle so much file volume. So there are different tools like, as I said, MLflow and Comet ML, which help you give you what is its capabilities, etc., in a tool format. Okay, so a new CI/CD pipeline is designed for ML teams, where in conventional CI/CD you go for the latest build, assuming that it is tested perfectly, and you also go for builds which have less bugs. Okay, those are your measures for integration in staging and prod, deployment in staging and prod. Okay, in ML world that's not the case. Even if you have some random version sitting somewhere, okay, it's even some random version is sitting on somewhere. If you want to switch the model from 1.2, from 2.1 to 1.3, from 2.3 to V2, or from V2 to 1.4, you need a different CI/CD strategy to do that model switching. Okay, so that is why there are very good tools which are available today, where you can deploy ML models with model switching. It is very recent. I'll show you one of the paper. One second. So recently, one of my team members, co-researchers, have come up with a ML model switching approach to deploy real-time traffic monitoring. I'll share its underlying papers to see how they do deployment on demand. Okay, so I'll share the paper. So it's a very recent work, which is like 27th February. I'll share the paper. I think it's called Edge ML Balancer, a self-adaptive approach for dynamic model switching for resource constrained edge devices. Okay. So how that works? Okay. Imagine you have a device which imagine you have a device. Okay. Let's take a IoT device like traffic signal. Okay, you have a traffic signal. Okay. There is a model which will send input to the traffic signal, which will the input for the traffic signal is the traffic potential inflow traffic. Okay, so at 10 a.m. the model is telling that, hey, you will get 10,000 vehicles, so the red color should be on for 10 minutes. Okay, at 11 a.m. you will get 50,000 vehicles per hour. Your red color should be 15 minutes. Okay, at 6 p.m. your vehicle are around 900, so it should be just 1 minute. Okay, this is how the traffic is getting a input. Imagine one of the prediction goes wrong, okay, in a given day, and someone who is monitoring these predictions figures out that among 10 attempts 7 are correct, 3 are wrong. Okay, the input which is being sent by ML model uh, is causing a chaos in the city because it's being dependent on real world. Now the idea is, can I replace with something which has a better approach or closer to more than 7.1 or 7.8 type of an accuracy. Okay, but this is an edge device or this is an IoT device, right? How do I do the deployment on demand? I can't replace the IoT device. So what people started doing is they are actually running the ML model from cloud. Okay, so there are companies like Monty Cloud, or you have a very nice company, forgot, I think Adani's company also has some of such setup, where they give you a ML model orchestration on cloud. Okay, so if you remember orchestration, you have ability to create your containers, right? The point is they will switch they'll create containers where each container contain model v.1, model v.2. Okay, imagine this is not performing well today. Tomorrow they will bring this pod down and bring this pod up and switch it, so that this becomes the input to the IoT device which is sitting in uh, um, the traffic signal. Okay, so such type of model switching happens in by doing on-demand orchestration, which we don't need to do in your conventional product development, because your results are not volatile. Okay, because here in real world most of the ML algorithms have the data coming, have the training data coming dynamically, which will yield in volatile results. Okay, on paper there could be an accuracy of 80 to 95%, but because of dynamic data coming in, if you end up with volatile results, you need to have an infrastructure to switch this model. Okay, so that you expect right data. I'll show you one example. Okay, if you there is a tool called Perplexity. I don't know whether you use it. If you look at Perplexity also give you an option to switch the models. Okay, these are reasoning models. So if you ask a question, for example, where is NIT Trichy located? Okay, okay, it gives some answer. Okay, now imagine you didn't find a right answer, or the answer is not complete. Okay, you should have an ability to switch from one to another and look at the response. Okay, because both are trained with different training set. This is just an example, don't be surprised if it returns same response. So this is, I'm asking Sonar, the first response was from some R model. Okay, so the intention behind this is, what Perplexity is doing in the backend is, it is actually switching your input to a different container which has an algorithm running, and you can get the output which is closer enough for you to determine which is right or which is wrong. Okay, these, see, look at the answer. So here it started with personalization. It's telling Trichy is a city in India, right? So it is like a conversation, but it gave some answer after thinking. Okay, but if you look at this model, Sonar have this, they don't have think logic, so it basically doing a string search and eventually giving you some references which it could read from internet. Okay, now a person who is taking a serious decision, this is just a search, but for traffic signal, but for someone who is trying to fine a person in a traffic signal, like traffic police wants to do a fine on a particular person, he needs to have a closer to 100% accuracy kind of a models. Okay, so for that you need to have a capability or a system or an infrastructure to do this switching. Okay, so people who work in MLOps become the custodian of that switching setup. Okay, this is not rocket science. The only difference here is, if you remember your orchestration class, we do see that people create multiple pods for developers to do development and have some save point to it and create some containers, so that whichever container is up, based on that container the particular dev will get access to build the product. Okay, here you replace the developer with the model, and his work we replace it with the traffic signal. Okay, so these containers are no longer physical machines, but they have code inside them which will run like a software. Okay, which has v1.1, v1.2, v1.3. So the orchestration in MLOps happen in such a way that You can also partition the response with different models. So for example, if I ask where is NIT Trichy, part of the answer I can render it from V1, part of the answer I can render it with V2, part of the answer I render it to V3, because I am orchestrating from one particular pod. Okay. People are working to switch between pods to improve the accuracy on demand. Okay, I know V1 accuracy is 60%, V2 accuracy is 70, V3 sometimes it is 60, sometimes it is 80. So how do I on an average give them somewhere close to 75%? Is you have to have a right orchestration, right MLOps team who can help you switch your model on demand dynamically so that you get closer to your benchmark. Okay. So those activities are typically taken care by the DevOps teams. Okay. Question is, how do they do that? Okay. So Kubernetes has an inbuilt a tool called Kubeflow. Okay, which will help you perform orchestration workflows for entire ML pipeline. If you look at typical ML pipeline, you have data development, then you have pre-processing of data, then you have model development, model curation, and deployment. Okay, what Kubeflow can or Ansible also has some plugin. What these things will do is they will ensure the bookkeeping of the entire pipeline for a given model version which is deployed, okay, which is released, sorry, not deployed, which is released. So imagine you have another model v2. It ensures that it maintains the entire pipeline intact so that when at a target end, when you switch from v1 to v2, you have an ability to tap into you have an ability to tap into the right pipeline. Okay, so that you read your correct train data, you read your correct model, and you read your correct benchmark, and then get correct results. Okay, before there was no Kubeflow, people used to mimic docker pods. Okay, before even Docker Swan was there, they used to create multiple containers, do the switching by writing Python code based on the accuracy. So basically, they used to have an accuracy filter here. For every response, they used to compute the accuracy of the response and perform dynamic switching of the model every 1 hour or 2 hours. So they basically monitor the output. If the output is less than the average accuracy, they will switch the model. So every 2 hours, they'll check average of it and switch the pods. Okay, because that is not scalable, because you need a lot of infrastructure on Docker. You have to move a lot of your pass onto your Docker and create thousands of containers, because you are not serving one targeted end user application. If you are serving larger population, then it could be a infinite setup. Okay, so for example, if you have to scale it, if it is a single traffic light, then maybe this approach will work. But if it's a traffic light for entire Hyderabad city or Trichy city, oh god, you will end up having a lot of images to switch, so that you give closer to accuracy of the traffic light. Okay, so after Kubeflow has came into picture, uh, people have outsourced their Python code of switching to Kubeflow. Kubeflow will now help you process which model to serve, at what time, based on the predefined accuracy you set. So, for example, if you are setting traffic light accuracy to be 80% correct, okay, it will go and search all the models the developers have built, which will give closer to 80% accuracy, and it will give that pipeline as an input to the traffic signal. Okay, so the MLOps team will ensure that this pipelines are up, they are functioning, If they are down, they have to do the disaster recovery to bring things back. And all these things are now easy by Kuberflow. I mean, 2023, 2024, you have Kuberflow and Unusable plugins which will help you do this. Okay. Um, One small thing we need to discuss is the deployment strategy. How do they deploy? Okay. If you remember, they usually deploy the conventional products through physical files, physical file movement. So, for example, if you have an HTML file where you're changing a logo, you will read the build from Git and remove the HTML file and reapply the new one. Okay, that is how you deploy in conventional dev teams. Okay, but in case of MLOps, they will keep the existing model alive. They will deploy the new model. While they switch the models, they will deprecate the older models. So it means that at a given point of time, all models which are deployed will be active at some point of time. But some models which are actually not being utilized or not being giving closer to accuracy will be deprecated. How? With certain frequency, like weekly basis. So every week there would be a job which will check the models which are not closer to benchmark, and it will deprecate them from the pipeline, so that when the switching happens, it will no longer touch the models which are not closer to benchmark. Okay, then it will eventually ensure that your model set which is input to your product will be closer to your benchmark accuracy. Okay, so that is how people eventually deploy, and the deployments are usually taken care by various ML serving tools. Kuberflow or Perfect ML is one more tool which typically helps. Okay, in this deployment process, one key aspect is logging and observability of these tools. Okay, today there are no strong observability tools for ML switching. Okay, primarily because not many applications do ML switching. People only enrich the same algorithm or same model and try to upgrade that model. People are now starting to do ML switching. That's why you will not find an ML ops team in every ML company. You will find in a top-notch company you have an ML ops team who facilitate ML switching. The key aspect is the ML ops team captures the logs, understands where are the fail rates. Okay, these are their Dora metrics for MLOps team. Fail rate of a model, how many answers did it couldn't respond, what is the percentage of unresponsive or hallucinating response or incorrect response. They will identify such models and flag them. Okay, so that the underlying developer teams who are building it will get the feedback, and they improve the new V3 V4 models for public release. Okay, so compared to conventional development, for ML development, observability is very key. Without an observability, they don't have a feedback loop to understand what is my failure rate, how is my model really working fine or not, or is it do I need to change the goals and motives of my ML model or not. Okay, so this is how typically the ML ops works. Okay, any questions before I just talk about AR VR for 5 minutes?
No, sir.
Okay, so let us look at my area of expertise, which is called VR, virtual reality, and augmented reality. This is where I did a lot of research. So, VR AR area is very interesting. If you look at conventional dev, you have cloud based tools for development, and you have to deploy on demand through orchestration tools. Okay. If you look at ML, you also have now cloud offering, you have model switching, and you have on-demand development using tools like Kuberflow. But if you look at VR AR products, tomorrow if you join a VR AR products or become a DevOps engineer, the great opportunity for you is to write all native code you have to write everything from scratch. There are no good tools to deployment. Why? Primarily because the output device of VRAR tools are either head mounted device or your mobile device. Here in case of ML, it can be IoT, it can be any other tool where the code can sit on cloud. Okay. Here in AR/VR, the code cannot sit on cloud. It has to sit physically on the respective hardware device to run. Why? Because of the composition of the files. Okay. If you look at AR/VR products, which are typical virtual reality or augmented reality products, you have high resolution, uh, high vector images. Okay, you have high quality audio. You have a lot of you need a lot of rendering engine to render those files. So when you have a high composition of files, you cannot run it from cloud and have to deploy manually. Okay, so that's why if you look at the emerging research areas, if someone has to pick up uh, if someone is doing their research or PhD program, uh, ops for VR AR is a very great space to do research. You can use AI or artificial intelligence based algorithms to solve problems. Okay. Primary problem here is, I mean, in short, there is no typical operations for VR AR. They follow conventional dev operations. But what we can do, okay, is an open question for people who want to do research. Okay. What is that open question? We cannot do on-demand orchestrated deployment in HMD or mobile device primarily because of file size. Okay, that's the primary stuff. If you look at conventional dev, maybe the file sizes will be in MB. In case of ML, even the file sizes may be in KB or MB. But if you look at VRAR, the typical file size of a large scene would be either in GBs or maybe close to TB. Okay. Now the problem is if someone has to change the VR scene or update the VR scene, switching such a huge file on a hardware, if it's running through cloud, is very slow. Okay, so we'll have to figure out a new novel approaches to perform remote deployment or remote accessing of code so that you can avoid this file size problem. Okay, there's another problem primarily because you have diverse teams in VR. Okay, why? If you look at the ML team here as an example, you have a data team, you have a model team, you have maintenance team. But if you look at VR, it is more complicated. So typical VR teams have a scene designer. First, you have a person who writes specifications. Okay, then you have a scene designer. Then you have someone who generates mock VR environments. Okay, then there will be someone who used to do modeling. They model the scene, they draw the scene in tools like Unity or Unreal Engine, okay, which are game engines by the way. Then someone does screenplay, which typically people do in movies. Okay, they do screenplay. Then you have an audio acoustic engineer who actually adds uh, audio to all the assets in the objects which are there in the VR scene, and then someone tests it and then performs a simulation tests and then release. So there will be a release team. So any slightest change in the requirement, if you carefully observe among all these people, will jeopardize the VR product a lot. Okay, because by the time people capture specifications in JSON, designer creates JPEG images, modeler creates uh, uh, sample model mock environments in tool like Blender, and they design tools in Unity, design the environment in Unity and Unreal. By this time, the file size would be typically in GB. Okay, and by the time they add screenplay, they add acoustics, it will become closer to a TB. Now if you add any change, or if there is a change in requirement, the entire dev process will become jeopardized. Okay, so that is why, because you have too many diverse people, it's very difficult to maintain consistency, clear versioning of a VR scene because of so many files. Okay, that is one of the open problem. That's why, operations for VR AR do not typically exist better these days. Okay, last problem for a VR AR ops is, how do you maintain versioning at a end user level? Okay, if you compare it with conventional dev, you know which version they are on because you control the deployment, because the end users typically see the products over internet on cloud. Similar to the case with ML, all the devices see that in typical cloud. But in case of VR AR, people download the packages, installation packages, and deploy them in their respective HMD. So if a new version of a scene is required, they have to delete the existing one and deploy it. It is like uninstalling the app and installing app in your mobile phone. Okay, there's no auto update feature. So this is a primary problem, primarily because of the file size again, because of different people. So if someone is using a particular HMD, they will not have a common standardized scene, because there are variety of head mounted devices in the world which have a portability problem. Okay, for example, if you look at your dev projects or dev products, if you take Swiggy works in any mobile phone which has internet. Why? It doesn't have device portability problem. In case of VR AR, the scene, whichever is built by a particular VR company, will be only baked or deployed for particular HMD. For example, Meta has a HMD, Apple has an HMD, Visuzu has an HMD. So all these people, you need to build a new package. Okay, and you have to deploy that package only. If you use the package of Apple and Visuzu, or Visuzu's package in Meta Horizon head mounted device, it will not work. Because of this device portability also, people have tough challenge in managing the developer operations for VR AR. Okay, so this is a rough overview on what it's gonna look like in future of operations. People will have very solid tools in MLOps. Research is required in VR AR for having better operations tools. By bringing the size of the file down, you can rely on the practices used by MLOps to do scene switching, switching from one immersive environment to another immersive environment over time, and give better experience. Okay, so this is what I wanted to cover, a rough gateway towards what people do in machine learning teams, so that if you join as a DevOps engineer, or if you become a DevOps architect, you will have some rough idea how those teams will work, what tools they use, how do they deploy, how do they do model switching, how do they do implementation, orchestration, etc., in a nutshell. Okay, any questions?
No, sir.
Okay, so that brings end to the teaching. You will have midterm and a final. I've shared question papers with Vinay. Professor Vinay will take care of it. Okay, great. Thank
Okay,
you
sir.
and have a great day.
Thank you so much, sir.
Thank you. Bye.